My name is Debbie Hudson. I work at the Bureau of Meteorology in Australia. When we want to assess the information that comes out of an ensemble, which is a process that we call verification, you have to compare a large number of forecasts with what actually occurred. And to quantify that comparison, there are a lot of metrics or statistical tools that we can use. But before you actually choose a metric, we have to decide what the purpose of our evaluation or verification is. What are we actually wanting to assess? So, for example, who is it that wants to know the value of the information? Is it a user that wants to know how accurate the forecasts are? Or is it maybe more tailored to a scientist who's trying to diagnose errors in the model? So, and you also have to look at what it is that you're actually assessing. Is it maybe probabilistic forecasts of rainfall or heat waves or tropical cyclone tracks? And how are those forecasts communicated? Are there certain thresholds that are important? So understanding what your purpose is in evaluating the large amount of information that's coming out of your ensemble can determine your method of assessing its value. So there are a lot of metrics that we have available to us, and in fact no one metric can really describe forecast performance. There are a lot of different aspects that interest us, things like accuracy, which is how the level of agreement between your observations and your forecasts. There's another attribute called reliability. Reliability tells us how much we can actually trust the probabilities that are issued in a forecast. Do they convey the right amount of certainty or uncertainty in a forecast? And there's something called skill, which is a relative measure. So it's looking at how good are the forecasts from your ensemble compared to another forecast set, like just say climatology. So different attributes or aspects of the forecast system have different metrics that we can use to assess the large amount of information that's coming out of the ensemble. Ultimately, though, for an end user, how valuable the information is determined by whether or not it can assist in decision making. And in Australia, I work with seasonal and some sub-seasonal forecasts, and we have a large community, particularly from the agricultural sector, that are interested in the forecast. So for them, the value is determined by how much it's going to aid whether or not they can make a decision. Ensemble-based probabilistic forecasts convey the certainty or uncertainty that is associated with the forecast. You can't get that information from a single forecast. I work with forecasts on sub-seasonal to seasonal timescales, and for us, ensembles and probabilistic forecasts are our bread and butter. But even on shorter weather forecast timescales, the very nature of atmospheric predictability means that there is often considerable uncertainty associated with a single forecast. That uncertainty is due to our incomplete knowledge of the initial state of the atmosphere, and also due to model errors. So as the forecast lead time increases, so the errors and the uncertainties grow. So if we can convey to a user the level of uncertainty in a forecast, then it can actually help with optimal decision making. A user can then incorporate the probabilistic forecast into a risk management framework. So yes, I do think that ensemble forecasts, probabilistic forecasts, are probably more valuable than a single forecast.